Hey everybody, Mr. Judson here. So let's see, this Thursday, which I guess is tomorrow, I need to have a meeting with everybody who is signed up with Central Washington trying to earn credit. And really this is a mandatory meeting. I need everybody to be there, okay? The only reason that you wouldn't be there is if somehow it just doesn't fit your schedule because there's something that's uncontrollable. Your family's leaving and going somewhere, which, obviously there's not a lot of traveling right now. I know there's a few people who have been working. Maybe you've got to go in and work. But I really need you to be there. Those who are working, I really wonder if we should be doing the Central Washington thing anyway. This Friday is the deadline to drop this class if you do not want to earn Central Washington credit. Now, you got to remember this. A C at Wilson High School is not a C at Central Washington. Your actual grade is what goes into Central Washington. Tacoma School District rules are vastly different than Central Washington's. Nobody is guaranteed a C or better. If anybody was thinking, oh, I'm just going to do Central Washington because it's a guaranteed credit. No, it's not. So we need to talk about all this and just make sure everybody's on the right page, okay? So tomorrow during office hours, 11 o'clock, there will not be office hours tomorrow. There will only be the Central Washington meeting. I need everybody to be there, okay? All right. So yesterday we talked about our double angle formulas, and we saw that the cosine of 2u or 2 theta, it doesn't really matter what we call the angle, could be 2x, was equal to either this, or there was one more option. Well, what I'm going to do is I'm going to use these two to figure out our half angle identities, because this angle right here, u, is half as much as this angle right here. All right? So if I could solve for this, I have a half angle identity. So let me start with these two right here. I'm going to ignore this. I'm just going to look at this and say, let's solve for the cosine of u. So I'm going to move this one to the other side. So I've got cosine of 2u plus 1 is equal to 2 cosine squared of u. And then I'll go ahead and divide by 2. So now I've got cosine of 2u plus 1 over 2 is equal to a cosine squared of u. By the way, these 2's do not cancel, right? This is really important we realize. The only time you can cancel numbers is when this whole thing up here is getting multiplied by 2. And I could look at that and say 2 divided by 2 is 1. I can't take a number and then part of an angle and cancel that. Even if this was a 2, I couldn't cancel those because you can't cancel things that are being added or subtracted to something else. Only things that are being multiplied. Alright, so now to get this by itself, I'll take the square root. And so what I get is cosine of u equals, now I'm solving an equation, so that means I need to put the plus or minus out here. And we'll talk about what that means in a second. The square root of cosine of 2u plus 1 over 2. So now when I look at this, I want to think to myself that this angle is half of this one right here. Right? If this is 10 degrees, 2 times 10, that's 20 degrees. So what I'm going to do is I'm going to write this slightly different. I'm going to say the cosine of theta over 2. That's how I recognize this as a half angle identity. This is the theta over 2. So if I put a theta over 2 there, the 2's would cancel and I just get theta. So this equals plus or minus the square root of a cosine of theta plus 1 over 2. So let's just make sure that this is clear to us. Here we said that this angle is half of this angle right here. Probably should have that in parentheses. And here, this angle is still half of whatever's written here. Okay, so we've got the same thing written here, we just wrote our angles slightly different. There's my first half angle identity. Now, the plus or minus really depends on where this half angle is, right? If theta happens to be 300 degrees, and I take half of that and I get 150, well, 150 is in the second quadrant, and in the second quadrant the cosine is negative, so I would choose the negative sign. This right here is a choice. Okay, we have to choose one or the other. We don't include both of them in our answer. You take a cosine of an angle, it can't be positive and negative at the same time, all right? So we have to make a choice right there with that plus or minus sign. All right, there's our first half angle identity. Let's do the same thing with the cosine of 2u equal to this. So if I say the cosine of 2u is equal to 1 minus 2 sine squared of u, then I want to solve for this right here. So what I'm going to do is I'm going to move this over to this side of the equal sign so it becomes positive. So 2 sine squared u. And I've got one here. I'll move this cosine back over and subtract it. Cosine of 2u. And then I'll divide by 2. Sine squared of u equals 1 minus cosine of 2u over 2. And then I'll take the square root of that. So I get sine of u equals, again, plus or minus, and it's still a choice. It depends on where this angle is at. The square root of 1 minus cosine of 2u over 2. And so again, I'm going to look at this and say, well, this angle u is half as much as 2u. So I'm going to write it this way. I'm going to say that the sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. And again, this right here is a choice that has to be made. I'll do the same example. If theta equals 300 degrees and you take half that, that makes this angle 150, and the sine of 150, okay, 150 is in the second quadrant, sine is a y-coordinate, it's positive in the second quadrant, so I would choose the positive sign. It just depends on where this half angle is located. So I think in our book, this is actually switched around. They write 1 plus the cosine of theta. So when you think of it that way, these are really very close to the same thing. It's just one we're adding, one we're subtracting. And if I had to memorize this, the way I do is the one where you add is where the trig functions are the same. The ones where the trig functions are different, that's where you have to subtract. But you guys don't have to memorize this. You get a note card on the Central Washington Final, and so we're okay with that. So what about the tangent of a half angle? Well, the tangent of theta over 2 is just going to equal sine over cosine, so it's going to equal this over this. There's still a plus or minus in there. What I have is the square root of 1 minus cosine theta over 2 divided by, the square root's going to include all this, so sine over cosine, so divided by this one. I'll write this as 1 plus cosine theta over 2. And so if I flip that over and multiply, what I get is plus or minus the square root of, I don't know if you guys can picture this, but when you flip it over, the 2 will be on top and the 2's will cancel. So what I get is 1 minus the cosine theta over 1 plus cosine theta. And actually our book takes this a step farther. They look at this and they go, well, that's a square root in the denominator, that's not okay. And so what they do is they multiply top and bottom by the conjugate. Square root of 1 minus cosine theta. Up here, square root of 1 minus cosine theta. So this fraction right here is equal to 1, right? Top and bottom are the same, so it's equal to 1. So all I'm doing is multiplying by 1. And what I get here is the square root of two things that are the same. So that's just 1 minus cosine theta. When I multiply this denominator, I have to FOIL it. So I get 1 minus a cosine theta plus a cosine theta. Those add up to 0. And then minus a cosine squared theta. And I still have to take the square root of that. Well, that's just equal to a sine squared using our Pythagorean identity. So I've got 1 minus cosine theta over the square root of a sine squared. Which, when you take the square root of something squared, you really just get that trig function. So let me just erase that and put a sine theta in there. There's our half angle for the tangent. So let's just summarize these three. So here's our summary. We've got cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. The sine of theta over 2 is equal to plus or minus the square root of, it's exactly the same except a minus sign, 1 minus cosine theta over 2. And then our tangent of theta over 2 is equal to plus or minus, again, depends on which quadrant we're in. And let's see, what do we end up with? We had 1 minus a cosine theta over sine theta. If you look in our book, they give another version of this. You know, instead of rationalizing the denominator, they rationalize the numerator, and it's also equal to a sine over 1 plus a cosine theta. This is on page 410. Okay, so if you want to look at that, that's where these identities are listed. Kind of interesting, for some reason they did not put these on the front page of our book, that front cover. I don't know why they didn't put the half angles in there, but they're definitely on page 410. They are definitely identities, and so that's where you find them if you want to make notes and write those down. All right, so let's do some problems here. So if the sine of theta is equal to 5/13, then find the cosine of theta over 2. Using these identities, you guys go ahead and try that. So when you look at this, you'd go, well, okay, let's see, I just have to use this right here, and in order to do this, I have to know what the cosine of theta is. So that's something we did back in chapter 4. If the sine of theta equals something, now find the cosine. We can do that, and once we know the cosine, then we can figure out what the cosine of theta over 2 is. So I'm going to go ahead and draw a triangle. It doesn't tell me which quadrant this is in, so I will just assume first quadrant. Anytime they don't tell you, just assume the first quadrant. Here's my reference angle. I know sine is opposite over hypotenuse, so that would be 5 and 13. Here I have to do the square root of that squared minus this squared. Legs you add. If it's a hypotenuse, you do that squared minus this squared. So 169 minus 25, that would be 144. Square root of that is 12. If that doesn't make sense, go ahead and just do the whole Pythagorean theorem. You can work the whole thing out. All right, so now I know that the cosine of theta over 2. So if this angle was in the first quadrant, then half of this is still in the first quadrant, right? So this is going to be a positive answer. I suppose you could look at this and say, theta could have been in the second quadrant because the sine is positive in the second quadrant. So really, this angle could be anywhere from 0 all the way up to 180. So if you do half of that, well, half of 0 is 0, half of 180 is 90. That means this angle is anywhere between 0 and 90. So we are in the first quadrant. And the reason I'm thinking of that is because I need to make a choice of which sign to use. And so I think what we want is a positive answer. So this will be the square root of 1 plus cosine theta. I know that the cosine is adjacent over hypotenuse. So I'm going to put 12/13 right here, all over 2. And so my first thought is I look at that and I see a complex fraction, a fraction within the fraction. So I'm going to multiply everything by the least common denominator, which is 13. So I'll multiply this by 13, this by 13, and this by 13. And those 13s will cancel. So what I'm left with is 13 plus 12, that's 25. 2 times 13, that's 26. And let's see, the square root of 25 is 5. Square root of 26, we don't know what that is. So, these kind of questions, I would really try and look for exact answers. That's what Central Washington's going to ask us for. And so I think we should work in that direction. I don't think we should just divide this and take the square root and write down the decimal. You can do that if you want, but you'd miss a half point because it's not the exact answer. And then no square roots in the denominator, so if I rationalize this, I get 5 root 26 over 26. There's my exact answer. What if we did the same thing and we had to find the tangent of theta over 2? You guys go ahead and do that real quick. All right, so here's our half angle for the tangent. So let's see, kind of the same thing. If this half angle is somewhere between 0 and 90, it means it's in the first quadrant and everything's positive. So I'll choose the positive answer. So I've got 1 minus the cosine, which is 12/13, over the sine of theta, which that was given to us at the beginning. That's 5/13. So I just have to simplify that expression. And so again, we have a complex fraction. I'm going to multiply everything by the least common denominator, which is 13. Let's see, these cancel, these cancel. So this time I get 13 minus 12, that's 1 over 5. There's my exact answer. All right, let's try a different one. All right, let's give this one a shot. It says here that they want us to use the half angle identities to find the tangent of 75 degrees. Now, we've done this one already. We did this last week with our sum and difference formulas. 75 degrees, I'm going to draw part of a unit circle here. If I put my 5 tick marks in here, 75 degrees is right here. So we could say tangent of 30 plus 45 and get the answer that way. But this time we're being asked to use the half angle identity. So, sorry about the bleeding of the ink there, it's kind of hard to read. So I want to look at this and think 75 degrees is half of what? Right? This angle is half of what angle over here? So if you double that, you'd get 150. And so what we're really trying to do is say that the tangent of 75 degrees is equal to 1 minus the cosine of 150 over the sine of 150. And because the tangent is in the first quadrant, or 75 degrees is in the first quadrant, the tangent of that has to be a positive answer. So we're going to choose the plus sign here, not the negative sign. Okay, you guys see if you can finish that up. All right, so let's see, 150 degrees. That's this angle right here. Okay, we got 180 minus 30, that'll give me 150. My coordinates for that point would be a negative root 3 over 2 comma 1/2. Okay, just taking it right off the unit circle. So to answer this question, I've got 1 minus the cosine of 150, that would be this right here. So 1 minus a negative, so I'd make that plus, root 3 over 2, divided by the sine of 150, which is 1/2. And so to finish this up, again, we've got a complex fraction. To get rid of that, we want to multiply everything by the least common denominator. And so those 2's would cancel, those 2's would cancel. Here I'd get 2 plus square root 3. There it is. And I think that's the same answer we would get if we use the sum and difference formula. But when I look at this, I kind of feel like this is a little bit easier. So this is not a bad route to go. Let's try another one similar to this. We'll just call this number 3. What if we wanted to find the sine of 22.5 degrees? And I want the exact answer. Now, prior to today, we'd look at this and go, no way, Judson. The only way I can get this answer is with a calculator. But now we want to think, using our half angle identities, this is half of what? 45 degrees. 45 degrees is something on the unit circle, and so we should be able to do this using our half angle identity. You guys go ahead and try. All right, so this should equal, again, 22.5 is in the first quadrant. Everything's positive in the first quadrant, so I'm going to choose the positive answer. So for sine, I've got the square root of 1 minus the cosine of 45 degrees over 2. So cosine of 45, we know everything at 45 is root 2 over 2. And we're in the first quadrant, so it's positive. So I've got the square root of 1 minus a positive root 2 over 2, which is just still subtraction, over 2. And so what I need to do is get rid of that complex fraction. So only denominator's 2, so I'm going to multiply everything by that. And so when I do that, I get the square root of 2. These 2's will cancel. Minus root 2 all over 4. And the square root of 4 is 2. So what I really have is the square root of 2 minus the square root of 2 over 2. And I know some of you are probably looking at that going, wait, you can do that? Can you have a square root inside of a square root? Sure, why not? Looks kind of weird, but there's no rule that says you can't do that. So if I wanted to check this on my calculator, I'll do the sine of 22.5. So let me get myself into degree mode. There we go. So sine of 22.5, and I got 0.383. 0.383. So now I'm going to do this as well. I've got the square root of 2 minus the square root of 2. So I'll arrow out of the first square root, I'll arrow out of the second one, and then divided by 2. And when I hit that, I see the exact same number, 0.383. So yeah, we got that right. All right, let's see if we can solve this one using our half angle identity. So I guess the first thing I have to think of is what's an angle that's twice as much as this, right? This is the half angle. The angle I have over here is twice as much. So if I double this, I would just get 14 pi over 12. And so let's see, 14 pi over 12, that would be the same as 7 pi over 6. So this should equal, now let's see, if I make my unit circle, my 7th tick mark, here's 6, here's 7 right here. So that's where we're at. And we got to ask ourselves the question, is the sign positive or negative in the second quadrant? Should be positive, right? Sine is the y-coordinate, everything's positive above the x-axis. So again, I'm choosing a positive answer. I've got the square root of 1 minus the cosine of an angle that's twice that size, 7 pi over 6, divided by 2. So we know 7 pi over 6 is the 14th tick mark. So here's 6, 12. That means we're down here in the third quadrant. 12, 13, 14, we're right here. And so the coordinates of that point are a negative root 3 over 2 comma negative 1/2. So what I want to do is I want to do 1 minus the cosine of this angle. So that's the square root of 1 minus a negative root 3 over 2. So you subtract a negative, it means you add that, divided by 2. Once again, we got a complex fraction. I think this is just going to happen over and over again. So we'll multiply everything by 2. And so these 2's will cancel. What I get is the square root of 2 plus root 3 over 4. And I know the square root of 4 is 2. So this is the square root of 2 plus root 3 over 2. And so again, we should just check it real quick. 7 pi over 12, that's this angle, that's 90 plus 15, that's 105. Sine of 105, and what I got is 0.966. 0.966. So I want to make sure this gives me that same answer. So now I'll do the square root of 2 plus the square root of 3. I'll arrow out of the root 3, then I'll arrow out of the other square root, and then divide by 2. And I got 0.966. Exact same decimal. So this does check out. I know we did that right. All right, so that's what we have for today. So today's assignment, number C16, this is off page 415 in our book. We're going to do 35 to 53 odd. All right, that's it, you guys. Have a good day. Don't forget, we have a mandatory meeting on Thursday to discuss some Central Washington stuff. Anybody who is still earning Central Washington credit, I need you to be there. All right? All right, stay safe.